Hey guys, and welcome to a new video. In this video here, we're going to do object segmentation with YOLOv8 from Ultralytics. So this is a new video in this series that we're going to do with Ultralytics. So I'm going to show you how we can set up the model. We're going to see how we can run it from the command line. We see some different examples. We'll go inside the GitHub repository and also Ultralytics documentation. And then we're going to see how we can use it in our own custom Python script, do live segmentation with a webcam. So we're going to open that up in a custom Python script, move it around and see how we can actually detect and segment out different objects. So let's just jump into it and see how we can use it. So we'll start inside Ultralytics GitHub repository. We're just going to scroll through it. So here we can see comparisons between the different YOLO models. We can see that this YOLOv8 model is actually like state of the art, both with regards to the mean average position, so the accuracy on the data sets, and also the inference speeds. So here we can basically just scroll through the documentation. You can see how you can pip install Ultralytics. This is the only thing that you need. And then we can also just run it directly with our prediction method or like our segmentation method inside of our command line. So let's just start with that. We're going to open up an Anaconda prompt. And then first of all here, we're basically just going to run this command. So let's just copy paste it. We can do our prediction mode, but we can also have segmentation. So here we're just going to do prediction. We can specify the segmentation model. So here we have YOLOv8. We can use like a nano model, the small model, large model, and so on. Let's use the small model. And here we just need to specify segmentation after that. And we can specify the source. So let's run this here and see the results. Now we can see that the results are saved to run, segment, predict. These are actually like some pretty awesome results. And as we're going to see later on, it actually runs fairly fast, especially if you're running it on a GPU. So let's now jump directly into Visual Studio Code, where we're actually just going to set up the model. So first of all, here we have our YOLOv8 model from Ultralytics. We're going to import this YOLO class, and then we basically just need to specify what model we want to use. In this example, we're going to use this YOLOv8 nano model for segmentation. So this is the pre-trained model. So here we just specified the video path. I have a video here called cars. We open up a video capture with OpenCV. We just specify the path. So yeah, we're going to open up the video capture. So while cap is open, we're going to read in a frame from our webcam. We store it in this frame variable. If we can read in a webcam, we're basically just going to pass that frame through our model. We will get the results out. Then we can also just plot it directly. We will get our annotated frame. And with OpenCV, we can use the imshow function to just show what we're actually annotating with our segmentation model directly here. If we hit Q on our keyboard, it will just terminate the program and break out this while loop. We're going to release our webcam and destroy all the windows that we have opened up. So let's now run this program here and see the results. So this is the direct output from our YOLOv8 model for segmentation. We can see that it's basically just segmenting out all the cars in this example. So this model function actually takes in different parameters. Let's just go into the documentation and see those. This is the input sources. So all of these things, we can pass that into our predict model. We can also see all the inference arguments. So we can set up the confidence score, intersection over union if we want to show the results. We can also specify that we want to save our like inference results into like a separate file, so we can actually like show them later on, or basically just save our results. Okay, so let's now see how we can run this on a live webcam. We basically just need to replace this with a 0. I've also added a timer here, so we basically just have a timer timing like the inference time, so we can also visualize and show our frames per second on our annotated frame. So again, we basically just time it with this perf counter from the time module. Should be able to run it now. It will open up our webcam. Let's just move it around. I'm running this on a 4090 RTX graphics card from NVIDIA. So this is like on the higher end, but you can definitely run segmentation, object detection, and so on with Ultralytics in real time with lower end hardware. So here we can see we get around like 50, 60 frames per second, depending on like the inference time. But yeah, if I move it around, we can see that this just works like pretty good. Of course, like if we're moving like too fast, it will miss the detections. If I move it around, we can also just move it around here to the background. Let's see, we have the chair. We also have a potted plant. We get a pretty nice bounding box around, or like both the bounding box, but also this segmentation mask around the chair, and also the potted plant in the background, even though it's like a pretty complex structure. We also have like a donut here in the background again, which is basically like a dog bed. It is a low confidence score, so that could be filtered out in the model function. Yeah, so we can do this live segmentation inference with Ultralytics with the new YOLOv8 model. In the upcoming videos, we're going to see how we can do custom inference on your own custom trained data set. So thank you guys for watching this video here. Give Ultralytics a subscribe under the video here, and also like if you like these videos. We're doing this whole series where we cover like everything with YOLOv8, both object detection, segmentation, tracking, post estimation. We're going to create some projects around it. So definitely stay tuned for that. I'll see you in the next video, guys. Bye for now.